Now that we have the power rule, we will enhance our powers of taking derivatives by looking at some properties. The properties of taking derivatives depend on the properties of limits. In particular, the limit as x approaches a of the sum of two functions, f of x plus g of x, can be taken by taking the limit of f of x by itself and the limit of g of x by itself, then adding the results of those two limits. Now, let's consider how do we take the derivative of the sum of two functions. So let's let j of x be the sum of f of x and g of x, and let's consider the derivative of j of x. Well, the derivative of j of x is equal to the limit as h approaches 0 of j of x plus h, and j of x plus h is j of x where each instance of x has been replaced by x plus h. So that would be f of x plus h plus g of x plus h minus j of x, which is f of x plus g of x. And this is all divided by h. Okay, getting rid of grouping symbols, we could rewrite this expression as the limit as h approaches 0 of f of x plus h. And notice back here we'll have a negative f of x plus g of x plus h, and again back here we'll have a negative g of x. And this would all be over h. Of course, I can write this as two separate fractions. I can write this as the limit as h approaches 0 of f of x plus h minus g f of x all divided by h plus g of x plus h minus g of x all divided by h. And then remember from before, so we're taking the limit of this thing, remember this entire expression, remember from before that the limit of the sum of two things was the sum of the limit, so I could take the limit of this expression by itself and the limit of this expression by itself, and I'll get the limit as h approaches 0 of f of x plus h minus f of x all over h plus the limit as h approaches 0 of g of x plus h minus g of x all over h. And this first limit would be the derivative of f. The second one would be the derivative of g, provided the functions are differentiable, provided those limits exist. So if j of x is equal to f of x plus g of x, then j prime of x is equal to f prime of x plus g prime of x. Or we might write this as f plus g of x, its derivative, is equal to the derivative of f of x plus the derivative of g of x. Okay. All right, we have one more property that we need to focus on here, And this comes from the idea that the limit of the product of two functions is the product of the limits. So the limit of f of x times g of x as x approaches a can be computed by taking the limit as x approaches a of f of x times the limit as x approaches a of g of x. Again, that's provided all of these limits exists. So now let's consider this. Let's consider how do we determine the limit of a constant times a function. So let's let j of x be c, a constant c, times f of x. And now let's try and determine the limit, or the derivative of j of x. Well, this is going to be the limit as h approaches 0 of j of x plus h is j of x with each instance of x replaced by x plus h, so that would be c times f of x plus h minus j of x, which is just c times f of x, all over h. Notice that each term in the numerator has a factor of c, so we could write this as the limit as h approaches 0 of c times f of x plus h minus minus f of x, all over h. And now we have the limit of the product of two expressions. So assuming each of the limits exists, I can take the limits separately and then multiply them after I get done. So this would be the limit as h approaches 0 of c is a constant, remember, times the limit as h approaches 0 of f of x plus h minus f of x all over h. And if these limits exist, well, the first one does. It's the limit of a constant, and the limit of a constant we've already seen is the constant itself. And if this limit exists, this is going to be f prime of x. So we have the statement that if j of x is equal to c of x times f of x, then the derivative of j is equal to c times the derivative of f. All right? Or we might write that the derivative of c times f of x is equal to c times the derivative of f of x. Okay? Finally, let's take a look at the derivative of the difference of two functions. All right, well, we don't really need to go all the way back to the definition of here. Let's consider j of x this way. All right, j of x is equal to f of x minus g of x, but that would be f of x plus -1 times g of x. So we can think of looking at it like this. We can think of it as the sum of two functions. Well, then if it's a sum of two functions, all right, the derivative by the first property, the derivative of the sum, well, we can take the derivative separately of each term. And in the second term, notice the second term is a constant times a function, and I'm taking the derivative of it, so I can take the constant times the derivative of the function. So this would be f prime of x, all right, plus a -1 times g prime of x from the second property that we've shown up above. And this turns out to be f prime of x, of course, minus g prime of x. So if j of x is equal to f of x minus g of x, then j prime of x is equal to the derivative of f of x minus the derivative of g of x. Or, writing this in this somewhat perverted notation, f of x times g of x, the derivative of that, is equal to f prime of x minus g prime of x. So we have the derivative of the sum is the sum of the derivatives. The derivative of a constant times a function is a constant times the derivative, and the derivative of the difference of two functions is the difference of the derivatives. All right, these rules, well, the first two, all right, basically say that the derivative is a linear transformation.